Hello everyone, my name is Koma Signolo. Welcome to another video by Attention Matrix, where we try to make learning fun and easy. Please comment, like, and subscribe if you would like us to continue making this content and you enjoy it or find it helpful. Now on to the next video. Let's get right into it. Okay, hello. Welcome back to our videos on financial mathematics and annuities. So in this video, I am going to go through an example where we actually do a calculation of an annuity calculation, and we are going to be applying some of the concepts that we covered in some of our earlier videos with the annuities. Okay, so this example that I have on the page here is from a past exam paper. I think it's from a 2008 past exam paper, November of 2008. It's a financial mathematics question. It's an annuity problem, and I think it's a good question to go through. So I have not actually I have not done this question on the side on my own. I have not gone through the solution yet. I have not thought about it. I will be doing it from scratch. So we will essentially be solving this question together, you and I, so that you can see my thought process, you can track my thought process, and you can see how I go about solving such questions when and if I get stuck. Okay, so let's hop right into it, and hopefully everything goes smoothly. So okay, so the question reads as follows: a farmer has just bought a new tractor for 800,000 rands. Okay, so I'm just going to underline the important things. A farmer has just bought a new tractor for 800,000 rands. He has decided to replace the tractor in 5 years' time when its trade-in value will be 200,000 rands. Okay, so a trade-in value is simply the amount of money that the farmer will get when he finally decides to sell the tractor. So a trade-in is essentially selling your equipment for a certain amount of money. In this case, the equipment is the tractor that the farmer has. Okay, so that's what a trade-in value is. You are trading in your tractor for some cash. In this case, it's 200,000. The replacement cost of the tractor is expected to increase by 8% per annum. Per annum just means per year, okay? Or every year. Okay, so that's the bit of information that we've been given there. We haven't been asked to solve for anything just yet. Okay, so 7.2.1. The farmer wants to replace his present tractor with a new one in 5 years' time. Okay, so the farmer wants to replace his present tractor with a new one in 5 years' time. The farmer wants to pay cash for the new tractor after trading in his present tractor for 200,000. Okay, so we have this 200,000 already. It's just a bit of repetition from their side. It's been given to us in the first paragraph. How much will he need to pay? Okay, so there's our question. How much will he need to pay? So essentially, we're just going to go through this question one more time, but as I'm going through the question, I'm going to be drawing sketches. I find it very easy to solve problems with sketches. Okay, so what we've learned so far is that the farmer has a tractor. Okay, the farmer has a tractor and he bought this tractor for 800,000 rands. Okay, for 800, let me just write my 8 a bit better. 800,000 rands. Okay, so this is how much the farmer bought his current tractor for. His current tractor costs 800,000 rands, right? And in 5 years, we got that from the question. In 5 years, so if we go back up to the question, in 5 years' time, the tractor wants to trade in his value for 200,000 rands. Okay, so a farmer has just bought a new tractor for 800,000. He has decided to replace the tractor in 5 years' time when its trade-in value will be 200,000. The replacement cost of the tractor is expected to increase by 8% per annum. I will explain what the replacement cost is as we're going through this problem. So 7.2.1 says the farmer wants to replace his present tractor with a new one in 5 years' time. The farmer wants to pay cash for the new tractor after trading in his present tractor for 200,000. How much will he need to pay? Okay, so this is the situation. We've got a tractor that cost 800,000 rands. So he's got this tractor today. He doesn't have the 800,000 today. He has the tractor. He bought the tractor for 800,000, and in 5 years' time, he wants to replace this tractor. Okay, he wants to trade in this tractor, so he wants to sell this very same tractor for 200,000. This is the trade-in value. He wants to sell this tractor for 200,000 rands. Right, so once he sells this tractor for 200,000 rands, then he wants to buy a new tractor. So use money. The money is the 200,000 rands, right? Use money to help pay for new tractor. He wants to use this money to help him pay for the new tractor. But we have a bit of a situation here. This 200,000 rands is not going to be enough to help the farmer pay for a new tractor. Why? Well, I like to give an example of bread. If I buy bread today for 18 rands, 5 years from now, I guarantee you the bread won't cost 18 rands. It will definitely cost more than 18 rands. So if bread costs 18 rands today, in 5 years' time, the bread might cost, say, 23 rands. What would have happened? The price of bread would have gone up in 5 years. Why? Because of inflation, right? Money loses value with time. Because money loses value with time, the amount that you have today of 18 rands won't be worth the same 5 years from now. 18 rands in 5 years will be worth less than what 18 rands is today, what 18 rands is worth today. The same thing applies here, right? So the farmer bought a tractor for 800,000 rands. And in 5 years' time, he wants to replace this tractor with another tractor. But in 5 years' time, the new tractor will not cost the same price. It will not cost 800,000 rands. Why? Because in 5 years' time, just like bread, just like the price of bread, in 5 years' time, 800 rands will not be worth the same value anymore, right? 800,000 rands 5 years from now will be worth less than what 800,000 rands is worth today. Okay, so then what happens is that in 5 years, the new tractor that the farmer wants to buy will be more than 800,000. It will be worth more than 800,000 rands, right? More than 800,000 rands. But how much more? What is that actual value that the tractor will be worth? Well, we don't know. We don't know, but we would like to find out. Okay, we'd like to find out. So let me just recap. Okay, let me just recap again quickly. We've got a tractor, right? We've got a tractor today that the farmer bought. The tractor that the farmer bought is worth 800,000 rands. It is worth 800,000 rands. 5 years from now, the farmer wants to replace this tractor. But in order for him to replace the tractor, he's going to need to have the funds to do so. A portion of the funds he will get from selling this tractor, okay, for 200,000 rands, but he needs a new tractor for more than 200,000 rands. So the tractor in red is the new tractor. This tractor will not be worth 200,000 rands. Let me try to draw it a bit higher up. Draw it here. Okay, so this tractor will not be worth 200,000 rands, but it will be worth some amount. I'm going to call this amount new value. Okay, or new cost. Let's rather say new cost. New cost of the tractor. The new cost of the tractor. How much will this new cost be? Well, we've been given a clue in the question, right? This is where they mention replacement cost, right? Replacement cost. They said to you the replacement cost of the tractor is expected to increase by 8% per annum. So, in other words, 5 years from now, 800,000 rands will increase by 8% per annum. It will increase by 8% per annum so that the new cost of the tractor is going to be that increased value of 800,000 rands, right? You're going to have 800,000 and it's going to be increasing per annum compounded yearly to the new cost, right? So the new cost will be the increased 800,000 rands. The increased 800,000 rand. It won't be 800,000. It will be more than 800,000. Just like I keep going back to the example of the bread, right? Bread might cost 18 rands today. 5 years from now, bread might cost 25 rands, right? It will have increased from 18 to 25. Same thing with this tractor. It will have increased from 800 to that new value. How do we get to that new value? That 8% will help us. It will help us get to the new cost. Okay, so remember, we're still going through the question and making sense of the question. Let's see. The farmer wants to replace his present tractor with a new one in 5 years' time. The farmer wants to pay cash for the new tractor after trading in his present tractor for 200,000 rands. How much will he need to pay? Okay, so now we get to the crux of the question. Now they're asking us, how much will the farmer need to pay from his own pocket? Okay, so looking at the picture that I've drawn here, how much will the farmer need to pay from his own pocket? Okay, so let's say own pocket. That's what we are required to find, right? How much will he need to pay? Remember, he has some money. He has a little bit of money. How much money does he have already in 5 years? How much money will he have in 5 years? He will have 200,000, right? He will have 200,000. And then he will have to be able to afford the new tractor, right? He should be able to pay the new cost. But in order for him to pay the new cost, he needs some money from his own pocket, right? He needs some money from his own pocket. And then therefore, the new cost of the tractor will be equal to the 200,000 that he has from the tractor that he's going to sell, plus the money that he will have to save up, right, from his own pocket. He'll have to find this money somewhere. Right? So this is the equation that we're going to use. New cost of the tractor, the total cost of the tractor is equal to the 200,000 that he will get from selling his current tractor from the trade-in, and the money that he gets, that he will have to save up from his own pocket. Okay, so they asked us, how much does he have to pay? How much does he have to pay? Well, he has to pay this amount of money, the money from his own pocket. But if you look at this equation here, we have two unknowns, right? The new cost, we don't know how much the new cost is, and we don't know how much money he will have to contribute from his own pocket. So in order for us to be able to calculate how much he will have to pay from his own pocket, we should be able to calculate the new cost of the tractor so that we can slot it into this equation and solve. Okay, so how much is the new cost? How much is the new cost of the tractor? Going back to the question up here, you will notice that they told you that the replacement cost of the tractor is expected to increase by 8% per annum. So here we know that, okay, if a tractor cost 800 rands today, right? 800,000 rands. If a tractor cost 800,000 rands today, and that very same tractor will cost 800,000 rands with an interest rate compounded annually in future, how much will this same tractor cost in that future? Well, we use the compound interest formula, right? We use the compound interest formula. P1i to the power of n. Right, because what does this formula do? Well, this formula helps us establish how much the current value that we have will be worth in future if we increase it with a certain interest rate over a period of time. Okay, that's what this equation tells us. And in this instance, the P, the present value that we are trying to establish information from or about, is 800,000. Okay, it's 800,000, that's P. So let's just substitute things in there and solve. Okay, so what we have is A, this is how much, actually instead of A, I'm just going to say this is how much the new tractor is going to cost in future. So I'm going to call it new cost because I've been calling it new cost. So new cost, this is A, right? New cost is A, is equal to 800,000. I'm actually going to write it down here. It's equal to 800,000, open bracket 1 plus 8%, right? 8% to the power of 5. Where do I get this information? From the question itself, right? It's been given in the question. The replacement cost of the tractor is expected to increase by 8% per annum. The farmer wants to replace his present tractor with a new one in 5 years' time. So that's where I get all that information that I'm substituting here. Okay, so what is my new cost going to be? My new cost, you just punch that in your calculator. We'll do that just now and you see what you get. Okay, I have a calculator here. Let's do that. So we've got 800,000, open bracket 1 plus 8%. You can say 8 over 100 or you can say 8%, doesn't really matter. Okay, to the power of 5. So let's do this. To the power of 5, because that's 5 years, and equal to. Okay, so in 5 years' time, the tractor will be worth 1175462. 11754. This is 1,175,462. Okay, so 1175. Let's write that down. The new tractor will be worth 1175. 1175. Cancel. 1175462. 1175462, comma, how many cents? 46 cents. 46 cents. Okay, so this is 1,175,462 rands and 46 cents. This is how much the new tractor will cost. This is how much the new tractor will cost in 5 years, right? So he needs to have a total amount of 1,175,462 rands and 46 cents in 5 years. But a portion of this amount, a portion of this total amount will be catered for by the 200,000. Remember, he's going to have 200,000 that he gets from selling his current tractor. So we can subtract this 200,000 from that value and then get how much he will have to contribute from his own pocket. Remember, this is the equation. This is the equation, right? This new cost is equal to 200,000 plus own cost. Okay, so we can just substitute the that value that we just calculated here. This is the new cost. So the new cost is 1175462, 46. This is how much the new tractor will cost 5 years from now, is equal to the 200,000 that he would have gotten from selling his current tractor, then plus the money from his own pocket. This is what we're being asked to calculate. Own pocket, right? Own pocket money from, this is the money from his own pocket. If we punch that into the calculator, what will we get? This is going to be that minus 200,000. It's essentially the total cost of the new tractor minus the 200,000, right? So I'm just going to, likely I have this value here, I'm just going to say minus 200,000. Okay, that's 975,462. That's 975,462. So from his own pocket, from his own pocket, he has 975,462, 46. Okay, so this is 975,462 rands and 46 cents. This is how much he will need to contribute from his own pocket. He has to find this money from somewhere, right? He has to find this money from somewhere. And that is the answer to that question. That is the answer to this first question, to 7.2.1. Okay, that's all you have to do. Okay, so 7.2.2 says 1 month after purchasing his present tractor, the farmer deposited X rands into an account that pays an interest rate of 12% per annum, compounded monthly. Okay, he continued to deposit the same amount at the end of each month for a total of 60 months. Okay, that's still 5 years. It's still 5 years. 5 times 12 is 60 months. So it's still 5 years. At the end of the 60 months, he has exactly the amount that is needed to purchase a new tractor after he trades in his present tractor. Okay, calculate the value of X. Let's break down this question. What are they asking us to do? What information have they given us, and what approach should we use to get to the answer? Well, they're saying 1 month after purchasing his present tractor. Okay, 1 month after purchasing his present tractor, the farmer deposited X rands into an account that pays an interest rate of 12% per annum, compounded monthly. He continued to deposit the same amount. At the end of each month for a total of 60 months. What do we have here? We have an annuity. Why am I saying we have an annuity? Remember what an annuity is. An annuity is a series of payments made into an account, right? The account that offers a certain interest rate. An annuity is a series of payments made into an account, a series of constant payments or same payments, right? In this case, we know that he's making a series of constant payments every month into an account that will allow him to save up to a certain value. Now, this is an annuity. What type of annuity is it? We know that we have two types. We've got the present value and we've got the future value. Is this the present value or is this the future value? Remember in a previous video when I explained the concept, you use the present value when you have money currently at your disposal. You've got money either from the bank or from another financial institution, but you've got the money with you today. At present, you've got the money. This is when you use the present value, right? You use the future value if you want to save up some money. If you want to save up some money, if you want to either save up to a particular amount or you just want to save money for the future. But the point is, you don't have money currently. You want to put in installments so that you save up some money to use in future for some purpose that you want to use it for. So which one of the two is this one? Well, you will agree with me that, okay, this farmer currently does not have money. What this farmer currently has is a tractor. That's all this farmer currently has, right? The farmer has a tractor, but the farmer does not have money, right? What does the question say? If you look at the end there of the question, they say at the end of 60 months, he has exactly the amount that is needed. At the end of 60 months, at the end of the 5th year, he has exactly the amount that is needed to purchase a new tractor. What is that amount? What is that amount? That amount is our future value, and we just calculated it. That amount that he needs to save up in order for him to be able to buy the new tractor is the value that we just calculated right now. He needs to save up 975,462 rands and 46. This is how much he needs to save up in order for him to be able to add this value to the 200,000 that he will have gotten from selling the tractor in order for him to be able to afford the new tractor. Okay, so this is a future value annuity. Okay, and they're asking us to calculate the monthly payments that he will have to make into this account in order to get to that value of 900,000 and something. Okay, so it's simple. It's just simply substituting things and solving. So the future value formula, you should get this from your formula sheet. There's no point in trying to memorize it. Your future value formula is equal to x open bracket 1 plus I to the power of n minus 1 all over I. Okay, this is the equation for your future value. I hope I didn't make a mistake. This is the equation for your future value, and you just substitute. What do you have here? Well, you've got f. You know that f is the value that you just calculated now. F is the money that you need to save up. This is the future value that you would like to have. You would like to have this value in future so that you can use it to buy the new tractor when you add it to the 200,000 that you're going to get from selling your tractor. So that we have already. Do we have an interest rate? Have we been given an interest rate? Let's go back up and see. Let's go back up and see. 12%, right? 12% per annum compounded monthly. Compounded monthly. Okay, so here you're gonna have 12%. 12% per annum compounded monthly. So you divide it by 12 because it's compounded monthly. When it's compounded monthly, you divide it by 12. When it's compounded quarterly, you divide it by a different value. When it's compounded semi-annually, you divide it by a different value. Okay, in this case, it's monthly, you divide it by 12, right? And N, we've been told, is 60 months. This was given to us also in the question. I'm going to go back up to the question. It has been given to us. That's 60 months there. Okay, it's been given to us, 60 months. So all the information has been given to us. All we have to do is substitute and solve. So now we solve. Okay, we've got our interest rate, we've got our F, and we've got our N. Now we solve. Okay, let's do that. What is our F? Our F is, actually I'm just going to rearrange, because we're looking for x now, I'm just going to rearrange this equation and make x the subject of the formula. In order for you to make x the subject of the formula, you take this entire thing there, you take it to the other side, and you take f and you divide f by this entire thing in blue. Okay, it's just making x the subject of the formula before you actually substitute. So you've got x is equal to, after rearranging, you've got x is equal to f, then you've got 1 plus I to the power of n minus 1, then all of this divided by I. Okay, so I just rearranged and made x the subject of the formula. Then you can substitute things. You can substitute. Let's actually do that. Let's substitute. You've got x is equal to, what is f? F is, remember, f is 975,462, 975,462, 975,462, comma 46 divided by 1 plus 12% given to us divided by 12. Don't forget to divide it by 12 because it's compounded monthly, to the power of 60 minus 1 all over 12% divided by 12 because it's compounded monthly. Okay, and then we can actually go and put this in our calculator and solve. Let's put this in our calculator and solve. Keep forgetting this. 975,462. It's actually here. 975,462. Anyways, I'm gonna clear. 975,462, comma 46. Okay. This divided by 1 plus 12 divided by 12, and that 12 there, remember, is 12%, right? I'm just gonna say 12%. Do not forget the percent, otherwise your answer is gonna be wrong. Then to the power of 60, because it's 60 months, minus 1. Okay, all divided by 12%, 12% divided by 12. Okay, just gonna put this in bracket for my sanity, just for my comfort. Just gonna put, okay, so that entire thing at the bottom there, and then that, let me just double check that I didn't punch in anything wrong, make a mistake somewhere. It doesn't look like I did, and I get an answer of 11,943 rands. Let's say 11,944 44. 11,944 rands. 11944. 11944. 11944. So that is gonna be 11944. That's your answer. This is how much you are going to, or the farmer rather, this is how much the farmer is going to be putting into his account at an interest rate, at a monthly compounded interest rate of 12% in order for him to be able to accumulate this money, right? For him to be able to get this money so that he can take this money, he can sell his current tractor for 200,000, take that 200,000, add it to this money, and get this new cost. Okay, this new cost that we calculated. Where did we calculate the new cost? This new cost that we calculated here. This new cost, this 1 million, this value that is more than 1 million there. Okay, so in order for him to be able to get to the 1 million, he will need to sell his tractor in 5 years. And after selling his tractor, take out the money that he's been saving up by putting in 11,944 rands into an account and then using it to buy the new tractor. Okay, so that's essentially how you would solve this problem. And this problem is actually an illustration of the concept that we covered, the sinking fund. Remember what a sinking fund is. A sinking fund is you using the future value formula to try to accumulate enough funds to use in the future so that you can use it for some purpose. Okay, whatever purpose, whether it's education, whether it's buying something that you want to buy, it doesn't matter. As long as you are aiming towards a specific amount of money and you are using the future value. In other words, you are putting in constant installments, the same value on a monthly basis, or on a as long as it's on an interval, right? You're putting money on an interval into an account in order to try to accumulate enough funds to use it for some purpose in future. This is exactly what the sinking fund is, and this example shows you exactly that. Okay, so let's go to the next question, see if we'll have time to solve it here. Okay, so 7.2.3 says, suppose that 12 months after the purchase of the present tractor, suppose that 12 months after, so at basically 1 year after, suppose that 12 months after the purchase of the present tractor, and every 12 months thereafter he withdraws 5,000 from his account to pay for maintenance of the tractor. If he makes 5 such withdrawals, what will the new monthly deposit be? What will the new monthly deposit be? Okay, let's solve this question quickly. I would like you to try this question out yourself, but I think let's just solve it. It's fine. Let's solve it. So essentially what happens here is that the farmer withdraws 5,000 from his account every year, right? They're saying, suppose that 12 months after the purchase of the present tractor, and every 12 months thereafter he withdraws 5,000 from his account. So every year he basically withdraws 5,000 from his account, and if he makes 5 such withdrawals, then how much will the new monthly deposit be? You will agree with me that the new monthly deposit should be higher, right? It should be higher because he keeps taking money out, so then it'll take longer for him. If he doesn't put in an extra amount into this, he has to put in an extra amount into that in order to make this amount of money in 5 years. Still, he still wants to make that amount of money, but he wants to take out 5,000 every year to maintain his current tractor. So what happens is that you've got 5 years, right? You've got the present, I'm going to call it 0. You've got year 1, you've got year 2, you've got year 3, you've got year 4, and you've got year 5. And he keeps taking out 5,000, right? At the end of the first year, he takes out 5,000. At the end of the second year, he takes out 5,000. At the end of the third year, he takes out 5,000. The end of the fourth year, he takes out 5,000. The end of the fifth year, he takes out 5,000. Now, this 5,000 rands that he keeps taking out of his account would have accumulated interest. It would have accumulated interest if he had not taken it out, right? You will agree with me that this first one would have accumulated interest for how many years? 1, 2, 3, 4. It would have accumulated interest for 4 years, right? For 4 years. This one would have accumulated interest for 1, 2, 3 years. it would have accumulated interest for 3 years. This one would have accumulated interest for 1, 2 years. And then this one would not, this one would have accumulated interest for 1 year, 1 year. And then this one would, the last one would have not accumulated any interest at all. So it would have not accumulated any interest by the time he takes it out of the account. Okay, so what we should do here right now is to calculate all the money that he deducted from his account with the interest that it would have accumulated, right? Because if he takes out the 5,000, he's taking out 5,000 at the end of the first year, but that 5,000 that he took out from the account would have accumulated interest and it would have grown to some value. So it won't just be 5,000, it'll be 5,000 plus the interest that it would have accumulated at the end of the 5th year, right? So you should remove all those 5,000s, and once you've removed all those 5,000s, take them away from the money that he should have had to save up, and then calculate a new monthly installment. Okay, so let's do that. Let's do that quickly. So for the first one, I'm gonna call it A1. So this one, I'm struggling with this thing. So this one I'm gonna call A1. This one I'm gonna call A2. This one I'm gonna call A3. This one I'm gonna call A4. This one I'm gonna call A5. Okay, I'm gonna call A5. So let us calculate what each of those values are so that we can take them away from the future value that we calculated. Okay, so A1 is equal to 5,000, including the interest that it would have gotten. What was our interest rate again? Let's go back up and see. He continued to deposit the same amount at the end of each month for a total of 60 months. At the end of 60 months, he executed that is needed to... Okay, so our interest rate is still 12%. Okay, but in this case, it's not compounded monthly. It's just compounded. It's compounded annually, right? So let's do that. Let us take it away. So that is going to be 12% over a period of 4 years. Why 4? Because this 5,000 rands that he took out at the end of the first year would have accumulated interest for a period of 1, 2, 3, 4 years. 1, 2, 3, 4 years. Okay. It would have accumulated interest over a period of 4 years, so it's going to be 4. Okay, and then we're going to have a value there. That's 5,001 plus 12%. That's 5,000. That's 1 plus 12%. Okay, and then that is to the power of 4. It's going to give you 7867,60. 7867,60. Okay, 7867,60 rands. So in essence, this 5,000 rands that he removed at the end of the first year is not just 5,000. You can see that he essentially removed 7,867 rands 60 cents from his account, right? This is how much he actually removed. This is how much he actually compromised. It's including the profits that he would have made. So for A2, we've got 5,000. And then you've got 1 plus 12%. And then this is going to be 3. Okay, why 3? Because for A2, where's A2? A2 is here. A2 would have accumulated interest over a period of 3 years. Okay, so that's 3. And then the next one is going to be 2. Then the next one is going to be 1 and so on. So this is going to be how much? Let's do that calculation quickly. This is going to be 7024,64. 7024,64. 7024,64. Then A3 is going to be 2 years there, right? 2 years, 6272. This is going to be A3. I'm not going to do the substitutions now. You see, you get the gist. 6272. Then A4 would accumulate interest over 1 year. You can see what I'm doing. I'm just changing the terms. It's going to be 1 year. That's 5600. That's 5600. Okay, then A5 is just going to be 5,000 because he's removing the 5,000 at the very last day of the term. So that's going to be 5,000. He removes it before it can actually accumulate any interest. So this is how much he removes in total, right? So in total, he removes, so for service, right, maintenance, for maintenance, even at the end of the term, it would make sense that he would remove the money at the end of the term so that just before he sells it, he maintains it so that he sells it in at least a better condition than it would have otherwise been in. So for maintenance, he's got A1 plus A2 plus A3 plus A4 plus A5. Okay, so maintenance, I'm just going to call it M. Maintenance is equal to, just add those values up, 7867,60, 7867,60, 7867,60 plus 7024,64, 7024,64 plus 6272, 6272 plus 5,600, 5600 plus 5000. So that's 31,764 rands 24 cents. 31764,24. 31764,24. Okay, so M is equal to R 31 what? 31764. 31764 764, 24. This is how much in total he removed from his account over a period of 5 years. See, it's not just 5,000 plus 5,000 plus 5. No, it's all the 5,000s and the interest that they would have accumulated. Right, so now all you have to do is take this M and subtract it from this little calculation that we did here. Subtract it from this little calculation that we did here, right? This calculation that we did here. Okay, because this calculation was telling us that you would have to put in a certain amount of installments. You'd have to put in a certain amount of installments in order for you to be able to get to the money that you want to save. Now, in this case, you're going to have to remove, you're going to have to amend this equation so that you can adjust your monthly installments. And your monthly installments, now you should know the kinds of answers you should expect in the end. Your monthly installment should be higher, right? Your monthly installment should be higher. So let's see. Our future value is F. Okay, wait, use black. Our future value is F is equal to X open bracket 1 plus I to the power of N minus 1 all over I. Okay. So you would have to take that maintenance value into account. So you're going to have to take all of this and say minus maintenance. Right, minus maintenance, or minus M, because I actually called it M. I can actually just call it M minus M. Okay. Okay, and now as you look at this, I just realized now that I made a mistake. This was based on monthly. The thing was compounded monthly. It was compounded monthly, and in my previous calculations, this was not compounded monthly. I made it compounded yearly. Okay, I made it to be compounded yearly. So the approach and the calculation and everything is right. It's just that this should have been compounded monthly. So this should have been compounded monthly. So what I'll have to do is, let me just quickly, it's going to be a long thing. These have to be multiplied by 12. All of these have to be multiplied by 12 because it's compounded monthly. Right? So then all my answers will change. These have to be multiplied by 12 and these have to be divided by 12. The interest rates will have to be divided by 12. Okay, so I'm just going to do the calculations quickly. The answer should be close to what I actually got, but it's fine. I'm just going to do it so that I get the right answer. Okay, so I'm not going to edit this video, to hide the mistake or whatever, because I want you to see me make mistakes, and I want you to see me catch myself with these mistakes and how I fix them and what the mistakes mean and why I say they are mistakes and how to avoid them and stuff like that. Okay, so learn to avoid these mistakes through my mistakes. Okay, so this stays the same. Maintenance is A1 plus A2 plus A3 plus A4 plus A5. I just want to compound them monthly, right? So let's do that. A1 will be equal to 5,000. That's going to be 1 plus 12% divided by 12 because it's compounded monthly for a period of 4 years times 12. 4 times 12 is 12, 24, 36, that's 48. Okay, so I'm just going to come here. I'm not going to do this calculation for all of them. Just going to do it. Let's say that's 5000, open bracket, 1 plus 12% divided by 12, close bracket, to the power of 4 times 12. That's going to give me 8061,13. 8061,13. Slightly higher than the value that I got. 80. So I'm just going to say, erase that. Then say 8061. 8061, comma what? Comma 13. Okay. Then A2 is going to be, I'm just going to use my calculator now. So instead of 4, that's going to be 3, right? That's going to be 3, 7153,84, 7153,84, 7153,84. Then A3 is equal to, that's going to be 6348,67, 6348,67, 6348,67. And A4 is going to be just 12. That's going to be 12 there. So it's going to be 12. That's 5634,13. 5634,13. 5634,13. And then we all know that A5 is going to be 5,000. A5 is going to be 5,000. Okay, 5000. Then I'm going to add these values up. Let's add these values up. Clear? I'm going to say 5000 plus 8061,13, 8061,13 plus 7153,84, 7153,84 plus, see, I like working through this together with you, 6348,67, 6348,67, 5634,13, 5634,13. Oh, I missed the plus sign there. Plus. See, 5634,13. Then I get 32,197. 32,197. Ah, see, it's close, but it's not correct. 32,000. It's actually compounded monthly, so you get more interest per month. That's why the value that I'm getting right now is more. 197,77. 197,77. This one is only compounded on a yearly basis. That's why the interest that you get is less than what I got, the answer that I got now. But you can see that they're close. The numbers are close. So that's actually a cool thing to note, that if you compound your interest on a monthly basis, you're obviously going to get more interest. It's a better deal, right? So let me write M there as 32,197,77. Okay, so we learned something useful from this mistake. Okay, so that's the value that you're going to have to take away. So from this formula here, right, from this formula here, you're going to have to subtract that maintenance amount. If you subtract this maintenance amount, you will agree with me that for us to keep this value the same while subtracting that maintenance amount, then that entire value will have to be bigger. But in order for that entire value to be bigger, that X will have to be bigger. The monthly installments that I put in on a monthly basis will have to be bigger. That's logic. So I'm expecting the answer that I'm going to get. The answer that I'm going to get, I expect it to be bigger than 11,944. If it's not bigger than 11,944, then I know that I did something wrong. It can't be less. It can't be. That's by logic. It has to be bigger. Okay, so this is how I want you to think about these questions. This is how I want you to consistently check yourself while you are working through these problems. Check yourself, check that your answers make sense. Okay, so we haven't actually done the calculation yet, but at least we know what to expect, what kind of answer to expect. It should just be bigger than that 11,000 that we calculated. Okay, so this one we calculated before. This one we actually didn't calculate it. Let's do it now. So what we are going to do, we want to find X, right? So let's make X the subject of the formula. X is going to be the subject of the formula. We are going to do this. We're going to take the F. We're going to say F. That's that F there. Plus M. Okay. This is that M there. It goes to the other side and it changes its sign. And then we're going to divide this entire thing by 1 plus I n minus 1. I'm just making X the subject of the formula. Okay, so X is the subject of the formula. So X is that thing there. This entire thing is equal to X. Okay, this entire thing is X. That's the new monthly installment that we want to calculate. So let's actually calculate it. What is F again? F is that, right? F is 975462. It's going to be a lot of substitution here. 975462, I believe. 975462,46 plus the 32,197,77, I think, that we just calculated right now. That's the maintenance, right? That's that. Okay, that's that, because we're adding them together here. F plus M, we're adding F and M, right? Divided by all of this stuff. Divided by all of this stuff. So let me put them in brackets so that I can divide by all this stuff here. So it's going to be 1 plus, what was the interest rate? Was 12%. Divided by 12 to the power of 60. So it's basically the same as the previous question here at this point. Then 12%, remember to put in the percent, don't forget it, divided by 12. For my peace of mind, I just love putting in brackets. It's a habit of mine that I have. Okay, just for completeness sake, completeness. It's fine, let's delete that. Okay, so that is what we're gonna have. I've got one too many brackets here. Go away. Okay, so you can just put this into your calculator and you'll see it will work out. So now I've got 12,338. 12,338. So I need my x to be x, my new x, I need it to be 12,338 rands, 24 cents. 24 cents. And this is the new monthly installment, or this is the new monthly deposit I'm going to have to be making into my account in order to still be able to buy the tractor at the end of 5 years. Okay, and my answer is bigger than the 11,000 that we calculated before. Okay, that is what I was expecting. It's bigger than this 11,944 that we calculated before, so I'm happy. So at least it gives me a little bit more confidence in my answer. I might have made a calculation mistake somewhere, somehow, whatever, but the answer that I'm getting makes sense. It makes sense, so I'm happy. So it gives me a bit of confidence. I'm happy with my answer, and therefore I'm going to stick with my answer. Okay, so this is basically how you approach these questions. Okay, just understand what is happening, understand what they're asking you, understand what piece of information to use when and how, and more importantly, why. I think the why is very important, right? Know when and how and why to use pieces of information and use them correctly so that you get answers that make sense, and consistently check your answers. Even while you're working through the problems, consistently check yourself, check your answers, check that your numbers make sense. Don't just take what the calculator gives to you. Check that it makes sense, check that you are on the right track. Just consistently check yourself as you're working through these questions and problems, and let this become a habit, and you will see that you will do wonders, right? You might not always get to the correct answer at the end of your problem, because you might have punched in a value wrong or a number wrong or a sign wrong or whatever, but the approach, as long as you can master the approach and understand what you're doing, you should be fine. Okay, so that's how you would address this exam question. And yeah, that's all that there is to this question. So we will do the present value example on a separate video, but as for the future value and the sinking fund, I think this video helps bring it home. Okay, till next time.